Hello, everybody, and thank you for joining us for today's Vertica Under the Hood webcast as part of our series. Today's is Geospatial Analytics at Scale with Vertica. My name is Jeff Healy, and I'll be hosting today's event, and I'm very pleased to welcome our speaker for today, Badr Ouali, Chief Data Scientist for Vertica. But before we get started, I'd like to encourage you to submit questions or comments during our event. To do so is really easy. You just type your question or comment in the question box below the slides and hit submit. We will have a Q&A session at the end of the event. We'll answer as many questions as we're able to during that time. And as a reminder, you can maximize your screen by clicking the double arrow button in the lower right corner of the slides. And lastly, the question we always get is, will the webinar be recorded and the slides be available? Yes, they will. To view on demand later today, along with a PDF copy of the slides. So let's get started. Okay, so I'm going to provide a very brief overview of Vertica. Talk a little bit about our competitive differentiators with some of the customers, how the customers addressing some pretty critical analytical use cases, and hand it off to Badr. So the question we get all the time, what is Vertica? Particularly when we run into a lot of engagements with these data-driven organizations, they say, well, we already have a database. Why would we need Vertica? And how do you handle analytics and machine learning? And there's also a query engine that you can use to explore data in data lakes. Yes, you can do all of those things with Vertica. So number one, it is a SQL database. You can load and store data similar to a data warehouse, and it's known for blazing fast analytics. So if you see any of the case studies on our site, you'll see some pretty amazing endorsements from our customers where they're able to take a workload from an enterprise data warehouse or maybe from an open source environment, and the queries can go from hours to minutes or minutes to seconds. It's an analytical database, meaning that there are analytical functions that run in the database that you can access right out of the box. And that's what Badr is going to dive into, specifically around geospatial analytics, but also machine learning we cover as well. So that you can build, test, deploy, store machine learning models at massive scale without any downsampling. And you can also run Vertica as a query engine. So you can ask complex analytical questions, get answers fast, regardless of where the data is. A key differentiator for us is we speak with a lot of clients, and they'll say, I've got the data here. I don't want to copy or move the data. If you can give us a solution to analyze that data in place, it's highly performant, highly scalable, we'll have a conversation. We have many of those conversations. So no longer do you need to move or settle on limited or partial use of your data landscape. So whether the disparate data exists across the organization, data warehouses, data lakes, cloud storage, within data science tools, business applications, and more, Vertica is a very highly performant analytical database platform that can give you that advantage without locking you in. And it's about future-proofing. So we speak with a lot of customers that have really bet big on one vendor, and we've seen history repeating itself, unfortunately, where you kind of paint yourself in a corner, whether that's you're moving all in on one particular shop around an enterprise data warehouse and all those tools, and you're spending a lot of money getting nickel and dime for everything, production service, development servers to extensions and what have you. That's not the case with Vertica. And then also, as we've seen, particularly with the Hadoop ecosystem, companies really aren't getting the value. It's a cost-effective and somewhat easy way to store and manage unstructured data, but getting the analytical value from that, deriving insights from it, has been a challenge. So that's where tools come into place, particularly very open environments like Vertica. It's not an open source environment, it's a very open platform. What's that enable you to do? Well, you can choose your own deployment, so whether that's on-premise, virtualized, hybrid, on all three major clouds. And it's hardware agnostic. You can choose the hardware that works for you, x86 commodity hardware. And we also have a mode within Vertica called Vertica Neon mode, where it's a separation of compute and storage architecture, particularly on AWS, where you have dynamic workloads. Very, very flexible, very elastic. And staying true from our vision from day one, we like to call out some of the innovations over time that not everyone is aware of. You can bring your own license model to any cloud with Vertica. You can bring it to the cloud, bring it back. Very, very flexible. Everything is included in the product. We don't charge you for development or sandboxes or things like that. We're constantly adding innovation to the core. It's a very simplified pricing model as well, whether it's price per node or price per terabyte. As I mentioned, you can explore data lakes. There's great integration with open source components like Kafka, Spark, and a variety of other tools within the Apache ecosystem and beyond. As I mentioned, machine learning functions directly into the database that you can access. Some of the most common algorithms that you've heard, if you're a statistician or an algorithm developer, like linear regression, logistic regression, naive Bayes, you can access those all out of the box with Vertica, and you can take advantage of the full cluster. So no need to downsample, and you can run, build, test, score those machine learning models at scale without being a data scientist, although we work very closely with data scientists, data engineers. Okay, so that's just the grounding or Vertica overview. I would encourage everyone to go to vertica.com/customers, check out all of our customer case studies. We have a huge library. We also have our sister webcast, which is the Data Disruptors webcast, where we have the top data-driven organizations that are, Vertica is really a core component of their data architecture so they can derive insight from those very large volumes of data. But everything, you'll see a lot of IoT analytical use cases. It's a very hot space right now where we have a lot of companies that are doing everything from predictive maintenance to wearables to smart agriculture and beyond, but also beyond IoT within retail for things like customer behavior analytics or clickstream analytics, whether you're a brick and mortar or e-commerce store. And then, as I mentioned, we're very open architecture. We work with a lot of the components that come out of the great community of open source. We work with streaming technologies, all the known ETL vendors, BI, data visualization, cloud vendors, and beyond. We have a partner engineering team that's constantly listening to our customers need better integration, because we understand there's not one tool for the job. It's a piece, a very critical piece of the data pipeline, but we want to make sure that it works really well for you. And lastly, before I hand it off to Badr, is that really, really excited about this. We have our next Vertica Big Data Conference. Please save the date. It's at the Encore Boston Harbor Hotel, which is just going to open in a couple of weeks. It's going to be a world-class event held March 30th to April 2nd next year. So go to vertica.com/BDC2020. You're going to see some very interesting and compelling speakers that we've already added, customers and third-party industry visionaries. So please check it out. It's going to be a great event. And now at this point, what I'm going to do is I'm going to hand it off to Badr to give the core of the presentation. Badr, why don't you take it away?
Thank you very much, Jeff. I'm really glad to be here. And today's topic is geospatial analytics in Vertica. The real goal of this webinar is to provide you possible solutions when you consider using geospatial analytics on a data volume difficult to handle by a single node machine. This webinar is also aimed at people familiar with data science, geospatial, and who want to find a solution to the challenge around this topic when dealing with big data. So before going deep into the subject, let me introduce myself. My name is Badr Ouali. I'm based in Grenoble, France, and I'm a data scientist and pre-sales consultant for the Vertica Analytical Database, which is a commercial fork of the original Cordano database project, C-Store. I've been working with Vertica for more than 2 years, and after 6 years of study and part-time jobs mostly in the research field, I decided to challenge my knowledge with this new experience. I'm mostly helping my customers to find solutions to their data science challenges and to get the most out of Vertica. And if you have any questions related to this webinar or topics, feel free to reach me by mail or LinkedIn. I'd be really glad to answer to all of your questions. So enough about me, and let's try to explain what you can do using Vertica Geospatial. So let's first see what we will deal with. So during this presentation, we will deal with many different Vertica functionalities. It will be mainly around geospatial, but we will also build the K-means model, for example. Do not forget that everything I will show you will be done inside a database without moving the data. It is one of the Vertica greatest advantage, but not only. When we speak about SQL, we sometimes forget all these programming language capabilities. SQL can be full of surprise, and Vertica SQL even more. Let's now introduce a bit the geospatial library, all the objects and the functions you can use with this Vertica library. So first, let's introduce the two supported spatial objects. This library will allow you to build two specific new types, the geometry and geography. The first one will allow you to deal with the Cartesian plane. It can be used if you're looking at the activity of a specific area. This area will be seen as flat, and every computation will be easier than working in a sphere. Geography, on the other hand, will deal with longitude and latitude, which means that we will consider Earth as a perfect sphere. We need to know the exact specificity of the use case to choose the correct type. When the approximation is quite good, the geometry type can be quite powerful, as it is easier to deal with a Cartesian plane than a sphere, which is totally normal in my sense. But we can also use a spatial reference identifier to project a geometry object in a specific space. With this kind of trick, we could see Earth as many small flat planes. Do not forget to think about the problem first in order to choose the best solution. For example, for some problem, we can try to find the faster solution, and for other problem, the more accurate one if we have time of computation. Many different spatial objects are available for the ones who are dealing already with geospatial in other tools. You can build your own points, multi-points, polygons, line strings. For example, a point can represent a user location during a specific time, and a polygon can represent a country, or for example, a Starbucks or any other grocery. So you can build your own object, and you can even load your own object using a well-known shapefile. But what's really interesting is the spatial joins, which is the most powerful function of the geospatial library. Spatial joins will allow you to identify spatial relationships between two sets of spatial data. So you can see many examples in this slide, like you can calculate the density of mobile calls in various regions to determine the location of a new cell phone tower, or you can calculate the number of customers in a retail store at any given time. In the following slides, in the real study, we will use a lot this function because it is the most interesting and powerful function of the library, and it will allow us to find in the study the golf player location. We have many geospatial functions, a bunch of functions in this library. So if you want to know all the geospatial functions like convex rule, distance, the space object intersection, etc., please take a look at the entire documentation. All the functions will be really well documented. You will have the output of the functions, how it works, and all the limitations. So many functionalities are available in this library just to simplify your geospatial journey. So in order to see how this library works, I propose right now to look at a very easy example first, and then we can go through the really interesting one. This example will help us to understand a bit the possibilities of the Vertica Geospatial library. So this example and many others are available in the Vertica GitHub. This one is a simulation of a museum tracking their visitors' location as they move through the space. We have 6 different artworks that visitors can view, and the purpose of this study is to find the most interesting artwork. And we will compute different metrics around the visitor's location, and we will see all the pieces of art like polygons. So we will do a lot of geospatial during this example. So here you can look at the 2 main tables, one with the artwork ID and the geometrical representation of it, another one with a time series of some customer location. Each piece of artwork can be represented by a point. However, however, to see the interest of each customer on each artwork, we need to define a perimeter around them. So if you look at the right side of the slide, you can see this stBuffer function. This stBuffer function is really useful to deal with this kind of use case because you can plot polygons around some points. So the geometry type, so you can plot polygons around each point in order to define a specific area. When the customer will be in this area, then it will be considered as an intersection. And as you can see in the left side, the geometry type is a binary type, barely readable. That's why we can use the function st_as_text to get the WKT representation of the object. There is also the possibility of importing or exporting the spatial object through a well-known shapefile, as I mentioned before. And now that we have all this information, we got some basics, so let's do some data exploration of the data in order to answer to many interesting questions. So when we look at the data, we can see 2,000 different customers during the museum open hours. We will create an index for each artwork. This one will be used to do the famous spatial joins. The spatial joins will return each intersection between the indexed spatial object and each customer location. 2 columns are returned. It will help us to count how many times a specific artwork was visited, for example. So let's look at this query. So the following query, with this following query, we can easily know which work of art was the most popular, for example. There is no gap in the customer location, so each intersection corresponds to a presence of 1 second around the artwork. We can arbitrarily also consider that a presence during more than 2 minutes, so you can see it in the queries that I'm filtering by 120, which means 120 seconds. And by filtering by this, I'm just looking at the visitor who spent more than 2 minutes around a specific work of art. We can then count how many customers were interested in each artwork. And you can see all the power of Vertica SQL and how it is easy to solve some complex problems, because here you will have the list of each artwork and the number of users who visited the specific artwork. And we can see that 4 is the most popular artwork. So let's go to the next slide and compute another really interesting query, because as the artwork 4 was the most popular, we're not looking at how much time does a visitor spend doing this piece of art in average. Again, as each customer record corresponds to 1 second, it is really easy to answer to this question by filtering by the considered artwork and using the average aggregation. The average time spent by customers around the most popular artwork, which is the artwork 4 that we discovered in the previous slide, is around 5 minutes and 30 seconds. We can also have many questions about this study, like at the busiest times of day, how physically close are visitors to one another, and it's quite easy using Vertica SQL. And we can really solve the problem with just few SQL lines here. It's the query that I made with a with is like an inner join, and we can see that at the end, at 12, the visitors were on average 2.2 meters far from each other around the most popular artwork. We can see how interesting this example is. However, I didn't show you the power of Vertica Advanced Analytics combined with geospatial and machine learning. So why not showing you something real? So today, I will show you exclusivity. Indeed, it is the study that I will show you is the result of an amazing POC. So we will deal today with golf players analytics. So let's see the context and the purpose of the study. The purpose of this study is to find golf players' location, knowing mobile users' ping. The study is location specific. It means that at the end, we just want to know some specific areas where people like to play golf. We can then build a specific marketing policy around an area. We can, for example, try to attract golf players to some golf courses the first days, as perhaps the golf courses are overcrowded the Fridays and empty the Thursdays. We can generalize the study to more complex use cases. But why not doing first some data exploration and preparation, trying to understand the data that we have, the limitation that we have, and the possibilities that we have in order to do some features engineering. So The purpose of the study is quite clear, as we need to find specific areas where people like to play golf. We will need, for this study, 3 main tables. So we need a table with all the mobile users pings in Canada. So here I just have the data in Canada, but we can generalize to any country. A UTC table to convert to the real date time. I will explain why in the next slide. And a golf table where we have all the golf courses across the country, specifically here among Canada. The question can be, why the need of the UTC table? So it's quite simple to answer to this question. The pings are ingested by the system using the UTC +0, and we need the exact date time to find golf players' location. To know where they live, we need, for example, the night features. It can be really interesting, or other features related to the exact date time, to know the exact location of each golf players. And then, having all this information, we can follow a possible strategy that is summarized in this slide. We can first map the correct UTC using the UTC polygons. It can be the first step. But then we can find the golf player's ID using mobile pings and golf courses polygon. Then find golf players' location using mobile pings. Use clustering to find the different golf players' areas. But do not forget that we are trying to do a study location specific. We don't care really about where they're living, but the area where they live. That's why we don't care about a precision of some user location. But at the end, what we will do, we will use the Vertica Geospatial convex hull property in order to determine the area's boundaries. So let's now look at the different UTC polygons. So we have 16 different polygons which will represent the different time zones in US and Canada. Vertica can handle polygons, multi-polygons, and polygons with holes. It's really important because for some countries, you can have a country inside the country, like, for example, in South Africa. So handling polygons with holes can be a great advantage. And then when we have all these polygons which will represent the time zone, we can look for each record to which polygon it belongs in order to associate the right time zone. We need to index the UTC polygons as well as the golf polygons. Indeed, the golf table includes all the golf courses around Canada. After this query, but there are 8 different time zones in Canada and more than 2,000 golf courses. You can see there in this slide below, 2,331 different golf courses. We can look now at the main table, the one including some of the Canadian mobile user pings. Sorry, I just go through the next slide. So here we can see the main table. And we can see the pings around some, not all, some of the mobile users in Canada. So we have for this table more than 800 million of records for only 1 month. But what you must know first is, like, with this kind of data, you can really reduce the number. Do you know why? It's a quite simple problem for telco company, for example, because when you look at the data, you can see that most of the time, the people will not move at all. So we don't need the pings each second in this study. And we don't also need information of a user who is not moving. And what we can keep, for example, is the number of pings he emitted to see if it is relevant. Because if the user just emitted 1 ping, it doesn't mean, it isn't really useful, because we don't have enough information to say that this guy didn't move at all. So what we can do is, like, when someone is not moving, we can aggregate the results, and we can so use the Vertica aggregation in order to know where he was at a certain time and how many pings he emitted. By doing simply that we can just use Vertica Advanced Analytics to filter and make the study easier. So as you can see here, we will solve this little problem using Vertica Advanced Analytics to compute, for example, the speed of each step, and we can also filter useless results. We can then filter using the speed. For example, if someone is not moving, then I don't have to keep the record in the database, and we only keep records where the user is moving and the number of ping he emitted. We also can keep we also can keep this number in order to be sure of what we are doing and not considering useless users. At the end, as you can see, at the end of this query, useful information represents only 15% of the data set. So now that our data are clean, let's try to solve the problem. Let's try to find the areas where golf players are mainly living. So as I explained before, the first step is to map the correct UTC. It is a simple usage of the STV intersect function, so spatial join. So a simple query will just solve this problem. And in the next slide, this one, we can see there the result of the previous query. And we can use the Vertica timestamp functionalities to easily convert the UTC plus 0 to the correct one. Let's now find who crossed golf courses as the first step is solved. So another easy SQL query helps us to answer the question. We need two main information for each user: how many times he spent in the golf course and how many pings he emitted. A small number of pings, as I explained before, increase drastically the uncertainty. That's why we need to make some arbitrary choices. We will do them right after finding user's location and merging the two information. So how can we find golf player's location? So we need to find the specific user's location. So to do this, we will fulfill 4 steps. So 4 main steps. The first one, we have to create a table with the new following features: the total traveled distance during 6 consecutive hours, because arbitrary, I will consider that if you don't move during 6 consecutive hours and you transmitted a number enough of pings, you were in a specific location, which can be your office, your home, at your parents' place. I don't care. So I will use these 2 variables in order to find approximately where the golf players are living. So the second step was, the easiest one was just to get the correct UTC solution, the UTC date time. And then we can compute a feature like night, the night features, in order to filter by night, because I'm not interested in the day for these users. And I will also create another variable, which is moving, is if the user has multiple locations where he stayed at night during the entire month. And I will explain why I don't need all of this information. So let's follow all the steps. So the first step is using moving windows in order to analyze each user movement during 6 consecutive hours. You can see the range clause, like in the query. This one brings an easy way to compute really complex features. And you can do a range clause using a timestamp or some rows. You can say, I just want to know what happens during the 10 previous rows. It's an incredible feature, and it can really hardly be done in Python or R. I'm coming from a Python background, and I really know how hard it is to do some moving windows and how many times it's taking. So here, you're doing some moving window inside the database without moving the data, and you get some really, really useful information with only few lines of SQL. And you can see all the power of advanced analytics in this query. So second step, quite easy. We just have to associate the correct time zone using spatial join. So this one will just be used for the next step. And then we have the third step, the most interesting one. We can then filter by night, where it is the higher possibility of each user location. As the study is location specific, we don't care about missing some golf players. We just need to have some golf players location to know where approximately golf players are living. We need to get some golf players to determine this area, and it is clear that some people will be detected sometimes at some other places, but we don't care. What we want is like a data set with a lot of positive records. And however, during an entire month, it is highly probable that each user will spend more at home than somewhere else. And let's go through the step 4, where we can finally aggregate and get the user's location that we will merge with the information we got around golf players. A user could have slept in different places the entire month, and we can create a variable which I called lat long gap, which is expressing the distance between the different locations. If it is small, the user slept the entire month in one location. So now when we look at it, we have now some locations we are sure of. But before merging with golf players' information, let's find some really useful mobile user. With the following query, really easy queries, we are trying to know users we are 100% sure of the location, the ones who emitted a considerable number of pings and stayed many nights at the same place. Based on 1 month of information, we can say that among 3.7 million different users, only 1.5 million users emitted more than 10 pings. From only 1.35 million, we have different possible locations. From only 306,000, we are mainly sure of a home, which represents more than 20% of the relevant users. And as I explained before, I don't need more than 20% of a data set, which represents a lot of different users. And now you will perhaps be impressed, because I will use machine learning right now. Now that we have all the information we need, let's find golf players' areas using a machine learning. So we can combine the different queries and only consider users who played more than 1 hour and who emitted more than 10 pings around the golf courses. We can call them golf players, okay? Really easy. We can then remove the duplicate and null row, and we are mainly sure of 445 golf players location. And I don't think that everyone in Canada is playing golf. So just this amount of golf players is well enough for our study. And you can see in the scatter plot in the right side, all the golf players location. You can see also 2 main clusters, and why not using an elbow curve to determine the suitable number of clusters. When we look at the elbow curve, we can see that 2 is a suitable number of clusters, and this elbow curve is just a loop of the in-database k-means. This function uses the scalability of Vertica, which means that even if we are using it with a huge amount of data, it will still work. I did it many times for many customers' POC. So here, okay, we are just dealing with 500 golf players, okay. But just imagine that you're dealing with much more. The study will still work. It will still work, and you will not have to move the data. And this elbow curve is just a method of visualization to get a suitable means is unsupervised, and we don't know this number in advance. So we can then run easily a k-means model with 2 clusters. You also have the get model attribute function that I used just right after to know the exact position of the 2 clusters. Quite easy, and you can do everything again using just slides of SQL. And after a quick search, we can then get the 2 main areas in Canada, which are between Toronto and Ottawa, and near to Edmonton and Calgary. In these 2 areas, people seem to really like to play golf. So to be even more precise, we can use the convex hull function in order to have the smaller convex space, which includes the different points. And guess what? So we can notice that it is probably better to erase the outliers first in order to have the 2% area, but we can get two compact areas, convex areas, where people like to play golf. After you could plot it in Earth map, it could be the same. I just use here Python to plot it. But just what I showed you is what you can do by only using Vertica SQL. So I showed you, I think, in my sense, a very, very interesting study, and we just arrived at the end of this study. So I just wanted to thank you all for joining this webinar, and I hope you are now able to see what we can do with the Vertica Geospatial and even more. I leave now Jeff taking the lead for our Q&A.
Badr, thanks so much. Great illustrative examples. I think the audience really enjoyed it. And we're getting some questions coming in, and we'll address those in just a moment. But I just wanted to address the question we get all the time, and that is, how can you evaluate Vertica? So the best way to evaluate Vertica is through the Vertica Community Edition. It's a free trial. It's a freemium edition. It's forever free, no time limit. You can store, manage, analyze up to 1 terabyte of data across 3 nodes. That's structured and semi-structured data through our Flex Tables innovative technology. You can run on-premise as a VM on all 3 major clouds. And there's an easy upgrade path to the commercial license. And everything that Badr showed today, all the geospatial pack, that is available as well to evaluate. So we've got some questions that are coming in, but I encourage others to ask more. And as I mentioned, we'll address as many as we can. And those that we can't get to, or if we need some other input to get them offline, we promise to follow up you directly. But let's get started with the first one, Badr, and that is, are spatial joins using indexes?
Yes, normally Vertica is not using indexes at all. It's a really, really specific case where they are using indexes. So we will index all the special objects because it will be easier to find them instead of using some really, really binary, tricky stuff. Because as I explained before, all the special objects are represented by some binary, they have a binary representation that is barely readable, and it's preferable to use some really easy integer in order to find them.
Very good. Thanks, Badr. Yep, we get the question again around slide deck copy. Yes, you will get the PDF copy of the webcast and recording today, so keep an eye out for that. You'll get an email. All right. Okay. Keep them coming, people. Next one is there any aggregate function for the geospatial types? About another question.
So for geospatial types, unfortunately, we don't have some aggregate functions, but there is a small trick which can be used by the over-aggregation. So because you have a function which can convert any geospatial types to a varchar, and then you can use a varchar using the list add aggregation in order to aggregate the results, and then you can convert them again to geospatial types.
Got it. Okay, no, that's great. Okay, another question that came in. You used an elbow curve and k-means. Is it really in database? And the machine learning functions of Vertica, are they scalable?
So yes, everything is in database. So as I showed you before, the machine learning functions of Vertica are coded from scratch in C++ and parallelized. I have many slide decks that prove, so compare, for example, the Vertica machine learning implementation to some other library like scikit-learn. But still, we are using some in-database machine learning coded from scratch. So yes, it is scalable. The elbow curve is just a loop of the k-mean. So I'm using different number of clusters in order to plot this curve. Quite easy. And everything is in Vertica without moving the data.
Very good. No, thank you. Okay, I think that covers a lot of the questions here. I want to encourage others from the audience to ask questions. And as I mentioned, if we don't get to all of them, we'll get them offline. But I think that covers most of it. Give it a few more minutes. Okay, no, I think we're good. Badr, thank you very much. Great presentation. As you mentioned, everything will be made available. But want to thank the audience for your great participation as well and for attending. So the views going up and up. So Badr clearly captured the attention of the audience. We'll respond directly via email, as you mentioned, for any other questions that come offline. You have both my email address and then also Badr's here. There is one question that came in, Badr, if you want to take a look.
Many other questions are coming. So
that's all I had to say is that it was ending and we got the questions, so it's good.
So how can Vertica be integrated with maps, like Google Maps?
Right.
Yeah, it's quite easy because just imagine that you have an ODBC or JDBC connection. You can then load directly the points using the Google Maps API. So after you just have to use your own types. It's a quite easy question, and it's not necessarily related to Vertica, but for any database you can just use any connection to your database and extract the points.
Great. Thanks, Badr. And I might as well just pile on. I know you know this question, but Esri is a partner of ours. How would you use Esri with Vertica? Have you used Esri at all, or any of those types of tools, and how are they complementary?
Jeff, I didn't hear you well.
Oh, sorry. Yeah, the question I had was any of the complementary tools in our partner ecosystem, Badr, products like Esri, E-S-R-I, I don't know if you're familiar with them, but you know, how would you work with them, and how does it enhance the geospatial analytical capabilities we have? Do you know? I don't want to put you on the spot on just those types of tools available.
Yeah, no, but I think at the end, when you will deal with geospatial, you can deal with your own tools. For example, me, sometimes I'm just using Python, you know, just to look at some things, or just Tableau, where we have a great connector to Tableau in order to have, for example, some geospatial data. And you already know that we have a great integration with Kafka, and we can do, we can, for example, load directly, ingest directly the data and plot them in a map. It's a well-known demo from Mark Welly for any other questions around Kafka and Vertica and Tableau. And we have so much, how can I say, connector to open source tools that at the end, when we understand how the library works, you can build like your just data science playground. Let's call it this way.
Mm-hmm. Okay, great. Yeah, and I'm very open. I use a lot of different tools and languages. That's great. I got a question around locating people for Micro Focus in Colombia, South America. The person who asked that question, I will follow up with you directly and make sure we put you in touch with the right people so that you can develop a relationship from there. Okay. Last call for questions again. Last time I did this, we got some more questions. Let's see if it happens this time, Badr. Let's give it a few more.
Yeah, is there example documented somewhere so we can look at SQLs used for data analytics? I have plenty of presentation, and what we are trying to do, for example, thanks to this webinar, is to introduce you some of my works. Indeed, we cannot introduce all the works because a lot are confidential. So that's why sometimes I'm trying to take data from Kaggle in order to accomplish some presentation where I'm free to present. I think that by the time you will have a lot of presentation like this one, like the slide deck that I just showed you, plus all the presentation that I would perhaps present during time, and I will share you some presentation. But if you want some specific use case, you can just send me a mail, and then I can try to get one of my presentation and share it with you.
Yeah, I'll pile on there, Badr. So there was a blog post that was published, I think, last week or the week before, where Badr talks about a wine tasting demo. So Badr creates a lot of incredible demos, and he has a lot of source code and things like that that he can share as an examples and extensions to show the power of Vertica, particularly within the realm of data science. So incredible resource, Badr. You get the email there, please reach out to us. We're happy to hear more and more use cases and how we can help you to address them. Okay, I think that's all for today. Again, wanted to thank the audience, and particularly Badr as well, for a great presentation. Note that a replay of today's event and PDF copy of the slides will be made available on demand shortly. And of course, we invite you to share them with your colleagues. Again, thank you to our audience today. This concludes our event, and have a great day.